Alright, so good morning. It is a morning, and I'm stuffy and I'm sorry, but we got to get to work. So, we're going to talk about today is expected value. So, I know we've been on probability forever, but we're going to stay on probability for the next couple of weeks. So, what expected value is, this is a note card, is, and I can't use the name in the definition, but it's exactly what it sounds like. It is, the outcome derived for a, let's say, for an entire probability, we'll just say probability problem. And you know me, I'll put them in very, very easy terms to understand. So, it is the outcome derived for an entire probability problem. So, in other words, instead of finding the x's and px's, we're going to find the entire, basically, px for the entire thing. It's not the same as average. Don't get me confused. Okay, so, first off, we need a problem. We're going to work through this together. And I'm going to try and go fast. You know me, in the mornings I go slow. But I'm going to make this a short video, I promise. Okay, so we got a problem where, this is going to be the roll the dice. Roll dice problem. Now, what I love about probability is a lot of it is common sense and just using logic to figure it out. So let's say this is the problem. You pay $10 to play. Okay? If you roll a 5, let me see. If you roll a 5, you get $20. If you roll a 6, you get $30. Okay? So that's the whole problem. And we want to know what's the expected value. The whole point of expected value is to see whether or not you should play. So that's the whole deal. You would use, and hopefully not you, but people use expected value in gambling all the time. All of the geniuses who play. So what we're going to do is do this problem. Hope you write that down because we're going to use it. So, first off, we need to make a probability distribution. So what are all my outcomes when I roll a dice? These are all my x's, remember? All of my x's. 1, 2, 3, 4. Okay. 1, 2, 3, 4, 5, and 6. Now, so I need to figure out my, sorry, I've got notes above the thing here. So, if I roll a 1, what's the probability of rolling that? Okay, we're going to make a probability. It is 1 out of 6. Probability of rolling a 2, 1 out of 6. Okay, and that's going to be consistent for all of them. Now, underneath all these, I'm going to make a third row here. And we're going to make this like our winnings column, okay? What happens if I roll a 6? If I roll a 6, I win $30, right? But how much did I pay to play? 10. So I really made 20 bucks. What if I roll a 5? Well, I make $20, but I had to pay 10 to play, so I really only make 10 bucks. Now, what happens if I roll a 4? I don't win anything, and I paid 10 bucks to play, so I'm in the whole $10. 3, same as 4. 2, same. 1, same. So now I've got what I make, right, versus the probability of that it happens. So, those are what I'm going to multiply together. Right? So, let me see here. Sorry. So, add all these up. What I do is I multiply straight down. Okay. Now, I ignore my first column, or my first row. Okay. So this row doesn't count. And I'm multiplying this times this. So 1/6 times negative 10. Okay. And what we're going to do is let's convert this into decimals. So this is 0.167. This is 0.167, 0.167, 0.167. Now, if you put it in your calculator, you don't have to worry about doing that. But I'm not using calculators, so that's what I'm going to do. So negative 10 times 0.167 is negative 1.67. So all of these are going to be the exact same. Okay, and then, oh, not this guy. This is a positive 1.67, right? And this one is a positive what is that? Oh man, my brain's not working. 3.4. Okay. Now, once you add them all up, let me make sure I'm doing all this right. Okay. Happening. You don't need to. Sorry, I know. I'm wasting your time. I apologize. Okay, now what you do is you add all these up. That's what I thought, but I was just making sure. So when I add all these up, what do I get? What I will get is my expected value. Now, this is very, very similar to finding the average, right? When you find the average, you multiply this times this, this times this, this times this, straight down and added. But now what you're doing is you're adding a third column, your winnings, and multiplying your probability times your winnings, and then adding up. So let me get a calculator, and I will add these up, and we will see what our expected value is. Negative 1.67 plus negative 1.67 plus negative 1.67 plus negative 1.67. So if I was in front of the classroom, I'd feel really awkward right now because there's all this downtime. But you can't actually. You're not actually in here, so it's weird. Okay. And I get a grand total of negative 1.67. Which makes sense, right? Because I have 2 and 3 positive ones, 1, 2, 3 negative ones, so I get that left over. So if I play this game, alright? What this means is if I played this game an infinite number of times, okay, I played 1 billion times, how much money should I expect to make? I should expect to lose $1.67. So the expected value is negative 1.67. So if the expected value is negative, are you going to play this game? No, you shouldn't play the game. Because you're going to make negative dollars in the end. Even if you get lucky and win every now and then, you're still going to end up making negative $1. In theory, not practicality, but in theory. Okay, I hope that makes sense. I know I've been in the way a lot. I'm sorry. Hope you got it. If not, we're going to work on it today, and you're going to get some practice. So, see, kind of a short video.